Thank you for coming. Those who don't know me, my name is John Fox with PCN. Today I offered to talk about VideoFlow and our transition away from satellite transmission to a IP solution over the public internet. And I just want to talk about the project that we put together and some information on VideoFlow. I'll start out by talking about the issues we've been having with our satellite uplink. Some of the considerations we looked at for the different IP options, the products that we had looked at, why we chose VideoFlow as our solution. Walk through some of the steps in configuring VideoFlow and getting a new site set up and on the network, and then talk about the timeline for this project and one event that dramatically changed the timeline for us from the original plan. All right, so some of the issues we've had with our existing satellite transmission. The uplink system was installed and upgraded last in 2002, and we've had it's standard definition only, so the equipment was badly in need of upgrading, and so we were deciding if we wanted to upgrade to high def on the satellite transmission or if we wanted to look at other alternatives. The cable systems that are receiving PCN over the satellite represent only about 6 to 7% of the cable homes in Pennsylvania. So there's 3.3 million homes that PCN is on. About 200,000 are receiving us over satellite, and the remainder is over a fiber network interconnected of different cable systems in Pennsylvania. So the cost of satellite remains the same, but a dwindling number of homes are utilizing the satellite transmission. So we're looking at other alternatives to save on costs. And some of the systems that want to carry PCN just can't put a satellite dish on their property. Retirement communities or hotels, universities that want to carry PCN, but they can't do it with the satellite dish. So some of the considerations for evaluating the different IP solutions, cost savings was a primary consideration. We wanted to make sure that whatever solution we came up with would save us money over our fixed costs for satellite transmission. We also wanted to make sure that reliability was there with automatic failover, backup systems, redundancy in transmission. So whatever the systems that we looked at, we evaluated the reliability, scalability, having the sites. We started out with 25 sites. We want to be able to eventually grow this to 50 or 100 sites, and want to make sure that we could expand to that amount and still keep our costs under our satellite transmission costs. And then flexibility in the encoding and decoding options on the system. The cable systems that we serve now were getting us over a standard def satellite feed. Several of them wanted high definition, so the solution we needed to come up with had to be able to transmit high def as well as standard def, and then ASI and composite outputs, so there's a mix of different wants and needs from our cable systems. So a couple of the options we looked at over the course of the last couple of years, many options were available that offer real-time and error-free transport over the public internet. A couple of those use a combination of public and private cloud solutions. All of these options do a good job of error-free video over the internet using their own version of or implementation of forward error correction and ARQ, or automatic repeat request. But the problem with most of these options was that we'd save money with the 25 initial sites, but as we looked at the cost as it was growing over time, then we were eventually going to end up spending more on this solution than we would on satellite. So most of them didn't make sense in the end for us. The option that we settled on, that worked best for us, is the VideoFlow solution. It is a software, digital video protection software that runs on the Linux operating system. So there's no more constant Windows updates. And it comes in different versions. So there's 4 different versions depending on the capabilities that you want for bit rates and number of streams, number of tunnels. It also, the software, the DVP software also comes in a virtual machine instance and can run on your own hardware. So, and that's what we did. That was our solution. We used VM on our own servers for the headquarters. And then at each of the locations, we then went with the smaller unit, the VXU unit, and that provided enough bit rates and capabilities for our cable systems. This system sets up a UDP VPN tunnel from point A to point B and transmits packets of information back and forth. And the VideoFlow solution is encoder and decoder agnostic. It doesn't matter what encoder and decoder you have at each end. You can do a unicast or multicast IP on the input side, and on the output it convert to unicast or multicast on the output. And you can adapt it, so you can start out with a multicast IP on the input, and then on the receive side, on the output, if you need to change the IP address, you go into the client system and you need a specific IP, either unicast or multicast, different port numbers. It's very flexible and can be adapted to the client's needs. And it also will handle MPEG-2, MPEG-4, HEVC. It's standard def up to 4K or even 8K resolution. So this system will transmit all the different versions that we need for now and for the foreseeable future.
So when we're looking at the max bit rate, that's a total bit rate of that particular block?
Yes.
Spread across the number of streams?
All the number of streams or tunnels. Yep. And so the other nice feature about this system is it's bidirectional. So you can set up, we have it set as from our headquarters out to the now 28 locations, but each of those 28 sites can act as a transmit site back to our headquarters as well. So we can now, from multiple points around the state, receive content if we so choose to expand in that direction as well. So it's just a very nice feature to have with this system. One of the criteria that we were looking at was flexibility. As I mentioned, that the VideoFlow system can transport multicast encoded in MPEG-2, MPEG-4, HEVC. We also needed encoders and decoders that could output different versions so that we fulfilled most of the needs of our clients existing and in the future. On the encoding side, we chose the Radiant Communications encoder. It takes an HD and an SD input and will output a multicast in either MPEG-2 or MPEG-4. So it has several multicast outputs and and it was a very flexible solution for us on the encoding side. And then on the decoding side, we use the WellAv decoder, which is now owned by Sencor, and they so the decoder, which you can see right here, can be set up as HD or an SD decoder, and it can output ASI, SDI, composite, or even convert the input back to an IP stream to go into their system as IP if they wish.
So they're passing the ASI, or they do a cherry picking themselves, or that's an external device?
That would be, yeah, they would be going into, yes. So.
Are they going to future handle 265?
Yes. Yep. Well, the VideoFlow transport can handle a 265.
As long as it's within the bandwidth constraints.
Yes. Yeah. Now the encoder and decoder we have for now can do MPEG-2 or MPEG-4. So when we're ready to do 265, then yeah, or adding another encoder and decoder. So the next consideration was reliability. So with this system, and I don't know if you can see the little snippets that I have down there, but on the server side, we can set up the input looking at two different encoder inputs. So you have a primary and a backup encoder. There's a primary input, so one encoder can have a multicast as a primary input into each of the servers, and then you can set up a backup encoder on a different multicast IP, and that would be an additional input. So if the primary encoder would fail, the backup would then be the source going into the server. And then for the servers themselves, the VM servers running the DVP software, they communicate with each other, and one acts as the active server and the other one's in standby. So it's in a high availability mode, so if the primary were failed, then the backup would take over and continue transmitting the multicast streams to all the clients. We also have two internet services, two separate ISPs, and the multicast streams are load balanced on the two. So, and there's enough bandwidth on each of those to take the entire load of the whole transmit in case one internet service provider were to fail. So we can do everything on one internet service. On the receive side, now we only have one internet service on the receive side. There isn't two, but each of the VPNs are set up to look back through to an IP address on each of the internet services. So they're looking at the primary VPN and primary stream coming in, and if that were to stop, then they'd switch over to the backup, and I'll show you the configuration on that later on. And then scalability of the system, we have, like I said, 28 sites on the network right now. We can expand that out to 100 or more than we see right now for our future growth. But we can always expand that even more if we wanted to. And most important is we can grow and still keep our costs below satellite transmission. So here's a larger picture showing the locations of the receive sites, so the cable systems throughout the state that are receiving us using the VideoFlow solution. And like I said, point from our headquarters out to each of the 28 sites, but they in turn can be set up as a transmit point back to our location if we wish to in the future. So in order to set up a new site on this system, there's 3 steps involved in the process. The first one is to create the VPN connections from the server to the client, and we go through first on the server side. We set up, configure the VPNs on each of the internet services, and then there is a configuration file that is downloaded and installed on the receive side, and then some further configuration done on the receive, the VXU unit, and then if you click on the connect now and connect the VPNs, if everything's configured properly, it'll be up and running. And in the event that you lose power on the remote unit, or you lose internet, and when it would come back, it would automatically reconnect the VPN on its own. Once you have the system set up and all the VPNs are configured correctly, this showing partial images of the status screen. So it'll show you for the first internet service the status of the VPNs, and we can monitor the connections and make sure everybody's up. And if there's a problem, if it shows a problem, it'll be a red status indication. So then we can call the cable system and let them know that there's a problem, or find out if they're having a problem and help them to get back online. On the remote site, then it shows you at the bottom here, you can see that it shows the 2 VPN connections through each of the different internet service providers, and green status is good and red is not good. Step number 2 is setting up the streams. So the list at the top here shows we have on the input side, we've got MPEG 2, MPEG 4 in standard def and high def on the input of the server, and depending on the client's needs, we'll choose which one of those inputs we want to create the outputs to send over the VPN connections to them. So so on the bottom right here, I've got it says hometown, and it's showing that there's we have 2 connections, 2 outputs to hometown, and then there's the hometown FO, or failover. So you have the primary VPN connection, and then the backup or the failover connection. That's the setup on the server side. And then on the client side, then we set up on the input, so we're setting up as a primary input, and then the additional inputs on the client side. So looking at each of the VPNs, the multicast streams coming into the through the VPN to the client receive box, and then setting up the output to go to the decoder on the client receive side. And then you can also, this is where you can go in and you can give it a new IP address or port number and customize the output depending on what the client needs. And then if all is working as it's supposed to, on the server side, you'll see again the status, the green status indications, and we can monitor all of the inputs and outputs going to each of our cable systems, and keep track of statistics for packet loss and requests and an unrecovered packet. So if we see something increasing as far as unrecovered, then we know there's an issue, and we need to work with them, the cable system, and try and find a way to resolve the problem. On the client side, this shows the input. So we get a green status, means we're receiving a good signal through the VPNs coming in, and then it tracks any statistics on that stream, and those statistics are then reported back to the server and kept track of on the server monitoring screen. And then the third step in setting up is to set up the remote management. So we can, from our headquarters, we can connect to any one of the devices on the network and get into the web interface for each of the devices and make any configuration changes we need, or if there's a problem with an output of the decoder, for example, we can go in and check the configuration or work with the client and try and resolve where the issue is. So on the server side, we set up a remote device, and we create two rules, one that goes to the VideoFlow DVP box, and the other one that connects to the decoder web interface. When everything's set up correctly, there's another page on the server side for web redirects that shows all the icons for either a DVP connection or a decoder. So you double click on the icon, it brings up another web page with the login screen for the device that you're trying to manage. So that's a very basic overview of how to set up and get a new client online. Like I said, we connect the VPNs first, then set up the stream outputs to the site, and then configure remote management, and then we have another client on our network. And the whole process takes from ordering equipment to set up and installation takes maybe 3 to 4 weeks to get somebody new on our system. So the project timeline for this, we were investigating the different options over the course of the last year and a half or so, and around May of last year, we finally made the decision that we were going to go with VideoFlow, that was the best solution for us, most flexibility, cost savings, and all that. And we had planned to roll this out over a 6-month period. So from July until December of 2017, we had planned on rolling this out to the 25 systems. However, on June 17th, AMC9 satellite failed, and that happened to be the satellite that we were transmitting on. And so we had to scramble over the next week or 2 weeks to move our service off of AMC9 onto SES, move this to SES2, and get the cable systems moved over to SES2. And we made the decision that we were just going to go full steam ahead with this project. Ordered all the equipment on about the 21st of June. Got everything in-house about 3 or 4 weeks later. Worked with VideoFlow and Digital Glue, who's the vendor on this project for us, to get all the products in, everything configured and ready for us to then take out in the field, actually, because Dean Vacher and Jeremy Baker and myself went out through the state and visited all the 25 sites and installed the equipment ourselves to make sure everything was up and running and working properly. So a 6-month project ended up being a month and a half or 2 months. We were up and running real quick. Everything was done in August, and at the end of August and all of September, we were doing both satellite and the VideoFlow IP over the internet. And at the end of September 30th, decided to shut down the uplink after 22 years in operation. And we've been on the VideoFlow system for the last 6 months exclusively. All right, so that's in a brief overview of our project, VideoFlow. We have the setup here is what the cable systems have. So we've got a demonstration of the VideoFlow device and decoder that we have installed at each of the cable systems, and then the output of the decoder showing a demonstration. And if there's any questions, I'll answer any questions, or we can come up and show you the interface closer detail if anybody wants any additional information.
How's the latency?
It's about 3 to 5 seconds.
Really no worse than
It's
satellite.
no worse. Yeah, it's better than digital cable, and just a little bit worse than satellite. Yeah, we can. There's ways to get that down even further, but there's at this point there's no need. Like 3 seconds is a good. Is good for us for this system.
Your decode does not have an HDMI output.
Yes, it does have an HDMI output. I can.
So what's the minimum requirement for the internet at the station?
At the station,
Yeah.
we have 2 300 meg internet services right now. We're pushing out close to 150 meg to the cable systems right now. So, yeah, 120, 130 meg, somewhere around there. So, so we're still under the 300 as everything was going through one. We can go up to 500 meg or even a gig if we wanted to on each.
The minimum at the head end,
And
we have, I think we have 2 locations that have like 3 meg connections. And so we're pushing 1.2 meg to them. I think.
it's 3 meg to them. So what you're seeing right now is MPEG-2 HD at 13 meg total. And we can go down right now as low as about 2.5 to 3. There's a couple systems that have a very low bit rate internet connection.
Do you have a separate encoder for each station you're serving, or each cable system you're serving?
No, we have 2 of the Radiant encoders. So one encoder for MPEG-2, do an MPEG-2 HD and an MPEG-2 standard def and multicast output. And then the second encoder is doing MPEG-4 encoding HD and SD. So, and those are the inputs into the server, the DVP VideoFlow server. And then from there, from the list of streaming inputs, depending on what the cable system wants, if they want MPEG-4 HD, for example, we'll take that input stream and create outputs for that new system. So then there'll be an output, 2 outputs, one for each internet service going to the cable system.
Okay, where are you doing bit rate reduction for the
So-
cable companies that want the lower bit rates?
That's in the encoder itself. So we're creating, I've got an MPEG-4 at 8 to 9 megabits and an MPEG-4 2.5 to 3 megabits on the so that's done in the Radiant encoder itself.
One radiant encoder gives you several outputs.
Just several outputs. Yep. Yeah. Any other questions?
Thank you very much.
All right. Thank you.
You should note that picture's coming down via Wi-Fi in here, right?
Yeah. Wi-Fi. Yep.
On this.
Yeah.
So what kind of pushback did you get from some of this, from the other end, from the receivers?
From the systems?
Yeah.
None really.
Wow.
Yeah, because we had looked at this. It was probably a 2-year project that we had done research, and I had we communicated with the cable systems, let them know we're thinking about doing this, and what's your internet capability at your head end, and can you even receive an IP signal? So they were all really receptive, and especially when we said that this system would be high def when the satellite was only standard def.
Oh, yeah, okay.
Then we want
Yeah.
HD. So
Okay.
Also, I think the mitigating factor was that when AMC failed, you were already on the project. You had already started the idea and planted the idea.
yeah.
It wasn't like, hey, guys, we're doing this now,
Yeah.
and you know, out of the clear blue.
Yeah.
No, it's true. They had some idea that this was coming. Yeah.
I was gonna say, I think the only pushback might have been from the one cable company who didn't have internet to the head end and really wanted our programming, and
Yeah.
we're like, well, and then eventually they did, by the time we rolled it out, they got internet at their head end and were able to pick us up.
Yeah, there was 2 or 3 systems that said we don't have internet, we're not going to be able to, and then eventually they're like, yep, well, we need to find internet.
Yeah.
They did. So.
I know when I was working at CMS, we didn't do constant feed, we only did the occasional uplink. And we got we wanted to go this route, but we got a lot of pushback from some of the smaller stations saying there's no way they can get internet. So I don't know what they have worked out. They may have gotten away from that, but I kept telling everybody, this is the way it's gonna happen. You know, you guys gotta get off the satellite because sooner or later.
Yeah, this is, it's been very reliable for us.
Yeah, the devices themselves are licensed for a certain amount of bandwidth. If we would do a video return, does that count against the licensed bandwidth?
Yes.
Okay.
Okay. Have you used any video return? I know you guys do a lot of sports around the state. I just wondered if you've
Not
ever.
yet. We our one decoder that we had has failed on us, and although we might get another one in time, but we talked about this possibly being used at swimming and diving coming up in March.
Okay.
We have 4 days of.
Yeah.
We had an equipment failure. Like, what are we going to do? So, well, this could be a solution, but so we might use it for that.
Okay.
We've also talked about using it at the Hilton. You've talked about
At the Hilton, yes.
because we have one of those at the Hilton, so they can pick us up and put them on the in-house, put us on the in-house cable. So that would give us the option to not have to use their particular internet. We can come back through that to send video when we do events there.
Yeah.